Hello, mathematicians. Thanks for joining us today. Arthur and I are happy to have you with us as we start planning out our garden. So the goal today is we're going to try to set up a garden over here, and what we want to do is find the optimal dimensions for that garden so that we can have as much area as possible. Alright, mathematicians, what you see here is that I've set up a preliminary fencing of what my garden's going to look like. Right now I have it set up so that it's in a rectangular shape, and what I want to do is figure out, okay, well, before I actually fix it in permanently with gardening stakes, right now I'm just using chairs to hold it in place to get an idea of what's going on, but I want to have a rectangular garden with the maximum area possible. Right now what we have is we have an 8 by 8 square laid out, and I have 25 feet of fencing. 24 of it's going to be usable because you can see at the ends here I have to secure it a little bit, and so the goal is then to find, can I find better dimensions so that I get a bigger area of my garden. Now that we've seen how we want to set up our fence for the garden, what we want to do is start laying out all the information that we have so we can draw a picture and keep all the information together. Now the first thing we notice is that, well, it is a rectangle, and so I'm going to draw the sides in, and the first side I'm going to draw in is the side where the existing fence is. Now I'm going to draw this side in on white to denote that I don't need to add more fencing here, but I can keep track of where it's at. After that, I'm going to draw in two black lines that are perpendicular to the existing fence, because those will be the two sides coming out from there. And then following, I'm going to draw the side parallel to the existing fence in yellow so that I can keep track of the four sides that make up my rectangle, and therefore the three sides that I need to fence in. Now, I drew the two sides that were perpendicular in black because I know they're the same length, and I'm going to need to assign a variable here because that's going to be changing, so I'm going to call that E for perpendicular, and the side that's yellow is parallel to the fence, so I'm going to call that A. A, because both start with P, so I just picked the second letter. It made sense to me. If you'd like to use different letterings, feel free. But what we have now is, okay, here are my variables. Here's a nice picture that I can refer back to as needed. Now recall that our goal was to maximize the area, so if we look at this, it is a rectangle, so the area will just be length times width, so in this case, it's just going to be A times E. We also need to remember that the total fencing we have available is 24, so if we look at this, we're going to have that 24 is equal to, well, I have two E's and one A, so 2E plus A has to be the total fencing of 24 feet. Alright, so if we look at the equation, the area is the parallel length times the perpendicular length. What we want to do here is we want to maximize this, so as we want to find A and E so that we have a maximum area. The problem we have right now is that in order to optimize a problem, we would find the critical points by finding the derivative, but we don't know how to take the derivative of an equation with two different variables in it yet. So what we need to do is we need to simplify this so that this is in one variable, and then we also need to find a domain that makes sense within the context of the problem. So the first thing we're going to notice is that if we want to find A or E in terms of the other, we have to use one of the conditions that was given to us in the problem. Now, the only condition that was given to us in the problem was that, again, this was a rectangular garden and I have 24 foot of usable fencing. So what I get is 24 was A plus 2E, which we already saw that, but now the point here is that if I use this, I can solve for A in terms of E, or E in terms of A. And so in this case, it's going to be a little bit easier to solve for A in terms of E. So then I'm going to subtract 2E, and I get A is 24 minus 2E. Now, since we have solved for A in terms of E, what we can do is go back to our original area function and say, well, A is 24 minus 2E, And then that's A multiplied by E. So the total area is going to be 24 minus 2E times E. Now we need to find the domain of our function, that is what E's or what perpendicular lengths will actually make sense here. Well, these are lengths, so our length should be greater than or equal to 0. So what we should have is that E is greater than or equal to 0. Because in our context, we wouldn't have a negative length. By the same token, we should also have that A is non-negative because it is also a length. So we should also have that 24 minus 2E is greater than or equal to 0 to ensure that the parallel side is non-negative. And so if I solve this inequality, I get 24 is greater than or equal to 2E, and so 12 is greater than or equal to E. And if I combine those together, what I get is the domain 0 is less than or equal to E is less than or equal to 12. Hence, by using the idea that, okay, these are lengths, they both need to be non-negative, what we get is a restricted domain for E. That is, we can't plug in any E we want. We can only plug in the E's between 0 and 12. Now, by doing that, notice that we've created a continuous function that is a quadratic, is continuous for all real numbers, but this one's continuous on a closed bounded domain, namely 0 to 12. So what we know here is that this function has to have both a absolute maximum and an absolute minimum. So those will have to occur at the critical points. So if we find the critical points, we can compare them to see which one's biggest and which one's smallest. Now that we know we need to find our critical points, we're going to look at our original function and remember that we find critical points by finding where the derivative is 0 or undefined. Therefore, I need to find the derivative of A with respect to E. So I'm actually going to simplify this first because if I take the derivative, it's going to be easier to deal with this one than it is this one. Here I'd have to use a product rule, whereas here I can just use power rules. Now, in that case, what we get is A prime is 24E, the derivative is just 24, minus 2E squared, the derivative is minus 4E. So the derivative of area is just 24 minus 4E. Now I need to find where is that 0 undefined. So if I look at where is this undefined, well, at first look, we see that this is a linear function, so we don't think it's going to be undefined anywhere. However, remember that I'm only defined on the interval 0 to 12, so my function is not defined anywhere but 0 to 12. So what we have is our derivative is undefined if we're outside of that interval, but it's also undefined at the endpoints. Since the endpoints are also in the domain, this means that those will be critical points. So I'm going to say this is undefined at the point E equals 0 and E equals 12, because at the endpoints our slopes of our secants and therefore tangents from each one of the sides won't exist, and so we have that these are undefined derivatives, so those will be critical points. We also have to find where the derivative is 0, so we're going to say our derivative is 0 if 24 minus 4E is 0. If I add the 4E, I just get 24 is 4E, so E is 6. Now again, I need to check, is that in the domain of the function? Notice that 6 is indeed between 0 and 12, so that is also a critical point. So we have our critical values at 0, 6, and 12. And what I want to do now is figure out which ones give me a max and which ones give me a min. So I'm going to go ahead and make a table with these. So I'm going to have my E values and my A values. And so the ones I need to check are 0, 6, and 12. And if I plug 0 into my area equation, I get 24 times 0 minus 2 times 0 squared is just 0. If I plug 6 in, I get 24 times 6 is 120 plus 24 is 144 minus 2 times 36 is 72. 144 minus 72 is just 72. And if I plug 4 in, I get 288 minus 2 times 144 is 288. Therefore, I get 288 minus 288 is 0. So what we notice is that looking at our values for my area, the absolute minimum area is going to be 0, which would make sense because we can't have an area smaller than 0. our absolute maximum area is going to be 72. So therefore, that's going to occur when E is 6. So we have a maximum area of 72 when E is 6. Now that we know that we have a maximum area of 72 when E is 6, what we have to do is actually answer the question is, what are the dimensions I should use and what's the maximum area of my garden? And so the first thing I want to notice was that E, recall, was the perpendicular length, or the length of the fence which is perpendicular to the existing fence. And recall that that was given in feet because the total amount of fencing was in feet. Now, we're also going to need to find A because that was the side that was parallel to the fence. And so what we're going to get here is that this would be the parallel length, which is also in feet. Now, if E is 6 feet, recall that A was 24 minus 2 times E, which in this case is 6. So we get 24 minus 12 is 12 feet. So what we're going to get is that the dimension should be 6 feet by 12 feet. And if the dimensions are 6 feet by 12 feet, my area will be 72 feet times feet, feet squared. So my total area is 72 square feet. Alright, so if we put this together, remember we had A was 72 square feet, E was 6 feet, and A was 12 feet. So if we were to combine this into a sentence explaining what's going on is, well, in order to get a maximum area for my garden of 72 square feet, I should make the dimensions of my garden 6 feet by 12 feet. Alright, now that we've finished our calculations, we noticed that the optimal size was 6 by 12. What I've done here is now laid out my fence in a 6 by 12 manner. And so, what we're going to have to do now is just go about and actually finalize that, put some garden stakes in, start trying to think about what in the world should I put in my garden. So, hopefully this helps you plan out your garden, but also maybe you can help me plan mine. What in the world should I grow in my garden? If you have any suggestions for things to grow in Virginia, let me know what grows well and what will do well in the weather.